Okay, this is Geometry 7173 quiz review. Not review, but just a debrief on this. And you guys can move to the questions you need. This is question 1. A model car, um, a model of a car is made. The car is 9 feet long and the model is 6 inches long. What is the ratio of the length of the car to the length of the model? Now, it's important to keep in mind I have to have the units the same. So when I'm looking at this, I have, and they say length of the car to the length of the model. Let me get this set. When I'm talking about the length of the car, I'm going to find the units for both of them to be together. I can either put them both in feet, or I can put them both in inches. But I don't want to have one in feet and the other in inches. Okay. So when I'm looking at this, I've got 6 inches at 9 feet. So let's put them in feet. And I've got the ratio of the length of the car to the length of the model. So car is first, model is second. And 0.5, because 6 inches is equal 0.5 of a foot. Okay, so I've got that going on, but my ratio needs to be in whole numbers. So I just double both sides and I have 18:1. So my selection for C is the answer. Now, I could have put it in inches, just if I wanted to go 9 times 12. And coming up with inches, that's 108. So 108 inches to 6. But now I divide 108 by 6, and lo and behold, I get 18:1. So I could have gotten either one as I look through the problem. Now in question 2, we're talking about red and gray bricks. Red and gray bricks were used to build a decorative wall. The number of red bricks versus the number of gray bricks was 5:2 in the total. So I've got this as a relationship from my red to gray. Now, it's important to keep in mind that I can represent this as 5x to 2x. There are 175 bricks used in all. How many bricks? And I've got to find out how many red bricks there are, I believe. So, yep, how many red bricks are there? So we'll slide this over a little bit so we can see everything in the frame. So I'm going to add up these, and we're going to retask the board again. So I got 7x dividing into 175. And when I do that, I divide out and find out that x is going to be 25. So we got 7x equals 175. X is 25. Now I got to keep in mind what that means. X is 25, so I had a ratio of 5x to 2x. That was red brick to gray brick. Now, because that was the ratio, I've got to keep in mind that I'm just going to be plugging that 25 in for my red brick. Okay, so there were 175 bricks used in all. How many red bricks were used? And there were 5 times 25 red bricks used, which is 125 total. In question 3, the ratio of length to width of a rectangle is 3:1. Now keep in mind, this is 3, this is 1. If the perimeter of the rectangle is 128, what's the length of the rectangle? Now keep in mind, perimeter is equal to 2 times length plus width. Well, if I got 128 and I know a length relationship is x, because that's that 3:1, it's 3x to x. So I've got 3x to x here going on. I've got length, which is 3x plus x, And so I got 4x times 2, which is 8x, and 128. Well, I take my 128 and I divide by 8, and I find out that x is 16. So x is 16, and they're asking me here, what is the length of the rectangle? And the length is 3 times 16, and it should give me 48 feet. Most popular wrong answer was 96, where you found the answer, but you added 3x plus x, and you came up with 4x, and divided by 128, and you came up with 32, and then you multiplied that out and found 96. Okay? So it's 16 is x, and 48 is the length of my rectangle. In question 4, a salsa recipe used with green pepper, onion, tomato, and has an extended ratio of 1 to 3 to 9. So really, that extended ratio becomes 1x to 3x to 9x. How many cups of onions are needed to make 117 cups of salsa? Well, I've got x plus 3x plus 9x equal 117. I got 13x is equal to 117. I take my 117, I divide by 13, and I come up with 9. So x is 9. Now, they're asking here, how many cups of onion? Okay, in the salsa recipe, onion was the middle ratio, so that's 3. So 3 times 9 is equal to 27. So 27 total cups of onion were needed for this recipe. In 5, the measure of the angles of triangles are in an extended ratio of 3 to 5 to 7. What's the measure of the smallest angle? Remember, again, 3x to 5x to 7x. Well, they're triangle angles, and so by triangle sum theorem, we have the 3 angles adding up to be 180 degrees. And now I just solve, and I got 15x is equal to 180, and I divide by 15, and I find that x is 12. So x is 12, but that's my first wrong answer, because they're asking me what is the measure of the smallest angle. The smallest angle is related to 3 times x. So 3 times 12 is equal to 36. That is my smallest angle. Selection A. Now, in question 6, they ask what is the solution of the proportion, and I just do a cross multiplication. So I've got 6 times 27 is equal to 18 times A. I divide by 18 on both sides, and I'm going to find that 18 goes into 6, and that's 3 left over. 3 goes in 27, that's 9. So 9, that's 18 is 1, is equal to A. So our value here for A is 9 for selection B. In problem 7, we have an extended ratio, another ratio, so this one's a little bit more involved. We have n minus 6, and when I do this multiplication, I'm going to multiply these two together. 3n plus 1 is equal to 3n times n minus 5. Now I've got 3n squared. My outside is n and negative 18, so negative 17n, and minus 6 is equal to 3n squared minus 15n. Now I combine things on both sides, and I subtract 3n squared, and I find out that those knock each other out. I take my negative 17 and I add it to the other side, so I got negative 6 is equal to 2n. And now I divide by 2, and negative 3 is equal to n. And that's our final answer. In problem 8, we're talking about the names or the ways we can manipulate proportions. Okay, so we're looking at means exchange, extremes exchange, adding 1, or reciprocal property. And I'm looking at, this is my original proportion, and the 8 and the B looks as if they've switched. So this is looking like it's going to be means exchange property, and since B and 8 have switched, it should be B over 15 is what I'm looking for, and that is our answer. In problem 9, they're talking about the fact that there's a relationship between these two rectangles. Two rectangles are similar. Which is the correct proportion for corresponding sides? Now, corresponding sides is 4 to 8 and 12 to 24. Okay, so I got 4 to 8 and 12 to 24. Now, remember, I can manipulate them around, but 4 and 8 need to be together, and the 12 to 24 need to be together. 4 and 8, 12 to 24. And for some reason, you guys don't have the right answer here. So if we're looking at 4 to 8 and 12 to 24, this has manipulation of 4 to 12. I could have gone 24 to 8 and 4 to 12. That's one possibility. 24 to 8 and 12 to 4. So by manipulating these, I could look at 24 to 8 and 12 to 4. Okay, or we could look at 8 4 to 12 and 8 to 24. Now, unfortunately, when we're talking about which is corresponding sides, we needed to make sure it was this one here, but the selections that were provided did not cover that at all. So we were looking from 4 to 8 and 12 to 24, and it's not here. Okay, so if we look at the 24 to 8, and 24 and 4, this isn't one, because 24 and 12, 8 and 12 needed to be multiplied together, and so it's 24 and 4, 8 and 12, so this is a possibility. 8 and 12 need to be multiplied together, so this is the one that would be the best possibility of the group of 4, but that one's still wrong because it's not corresponding sides. The corresponding sides is this one. Okay, so we'll talk more about that question 9 later. I'm sorry about that screw up for the choices. In question 10, you want to draw an enlargement of the design of a card that's 4 inches by 5 inches. You'll be drawing the design on a piece of paper that's 8.5 by 11. What are the dimensions of the largest complete enlargement you can make? So I got two choices. I got 4 to 8.5, as 5 is to, I'm going to see if that's big enough. 4x is equal to 42.5. And I divide by 4, and that 42.5 if I divide that by 4 is 10.625. Totally will work in that paper. Let's see if I can make it bigger on the other side. If I do 4 is to x and 5 is to 11, which is 44 is equal to 5x, and I take that 44 divide by 5, and I get 8.8. Now, this is too big for the paper because it's bigger than 8.5. So my dimensions here is going to be a picture that's 8.5 by 10.625. Okay, and my 10.625 is 10 5/8. So I've got 8.5 and 10.625. And that's my selection for problem 10. and 11. I got a scale drawing, and in a scale drawing of the solar system, scale 1 millimeter. So I got 1 millimeter is 500 kilometers. Okay, so I got 500 kilometers here. For a planet with a diameter, and this is millimeters, for a planet with a diameter of 5,000 kilometers, what should be the drawing? Okay, so if it's going to be 5,000 kilometers, what is the size of the drawing? And all I did was multiply by 10 top and bottom, so the drawing should be 10 millimeters. In 12, we're looking at the idea I've got these two triangles, and I've got to use Pythagorean theorem, triangle sum theorem to find the remainder. So I got 84.6 plus 66. That's going to be 29.4. Okay, and since that's 29.4 and not 30.4, these two triangles are not going to be similar. Okay, I pretty much know they're not going to be similar by angle similarity, but I'm using that idea that two angles have to be the same. In problem 13, two triangles similar. How do I know? Okay, well, I've got a bow tie. This is congruent to this, and this angle are the same. So these two triangles are similar by angle similarity. In 14, I've got overlapping triangles. So I'm going to be using side angle side similarity. Okay, and the sides that I have is the smaller triangle. I got 30 is to 40. And I'm going to see 3 is to 4, and they happen to be proportional. So not only corresponding sides are proportional, because this 30 is to 40 as 3 is to 4, okay? But now I've got to look and check out my angles. So I go OMN to OJK, and that's the order I want, but I want side angle side, so I want selection B. In 15, I have angle similarity. See you folks, have a great day. I have angle similarity. So I've got 21 is to 3.5 as 30 is to 5. Now I got to make sure that that's right. 21 divided by 3.5 is equal to 6 to 1. And this is also equal 6 to 1. So these sides are proportional. So now I can say that I've got that the sides are proportional. I've got two angles. Really, because of these two angles, I would have gone first to angle postulate, but because my sides are proportional and the angles, I can actually go after, and it's two sides, and I got my third angle, by third angle theorem, I could talk about side angle side. So I'll have to check that out for y'all when you look over your answers. In problem 16, I have a setup where this is triangle, this is the mid segment of a triangle, okay, because this and this are equal, this and this, so this is the mid segment because that's the midpoint to midpoint. So half of 60 is 80, and this is true. Or I would go, okay, I've got 144 in the small triangle to 288 in the big triangle. I've got X in the small triangle, and I've got 160 in the big triangle, and I could go like this and leave it. It's 288. It's equal to, if I multiply 160 on both sides, that's what I'm doing to solve for X. I get X, and I'm going to find out that it's 80 when I'm done. In my last one here, in problem 17, My last one here in problem 17, I've got to set these up. And it's the order in which it's going here that I've got it set up. And I got 92 in one triangle to 82.8 in the other. And I've got 82 to 73.8. And I'm going to check to make sure that those two are proportional before I move on here. I've got 92 divided by 82.8. Okay, and that's going to be 10/9. And then I've got 82 divided by 73.8, and that also is 10/9. So these are proportional. I've set those up for my side, so I've got 10/9 as my scale factor. So I'm going to use 10/9 because that's easy numbers, and a 10 is from the big triangle, so 47 is from the big triangle, and x 9 is from the small triangle, and I'm going to find x. So now I've got 10x is equal to 47 times 9, which is equal to 423, and x is equal to 42.3. So it's selection A. Okay, I hope this explanation of things works well for you, and if you have any further questions, please let me know. Have yourself a great day.